Chapter 11 focuses on randomization, how randomization is used as a tool in statistics, and how to apply randomization to simulations and how we use those to create simulations to help us model real-world situations. To start, while randomization is a very simple concept to understand, it's actually a very complicated subject. The reason being that the human brain really can't generate random numbers. If I asked you to give me a random number right now, you just couldn't do it. We're all inclined towards certain numbers. We all have favorite numbers. If I asked you to give me a number between 1 and 10, most people tend to give the same answer more often than not if you're asked that same question over and over again. Okay, now computers do a bit better job than humans do, but they actually can't give random numbers either. There are ways we can get random numbers, such as rolling a die, flipping a coin gives random responses, but as simple as those things are, it's difficult to get truly random numbers in a repeated fashion. So for example, a number between 1 and 100 that's truly random is difficult to get. So in this chapter, we're going to be using pseudo-random numbers, okay, which are numbers generated by a computer that are somewhat random, to create a simulation that's going to represent a real process to kind of mimic a real-world situation. Now, I just mentioned pseudo-random numbers. These are random numbers generated by a computer. As I just mentioned, they're not truly random, but for our purposes, we're going to consider them random. Okay, now back to simulations. Here's some vocabulary words we want to go over before moving forward. So within a simulation, the most basic event is termed a component. We'll have many components that we're simulating within these next few slides. Okay, many components make up a trial. It's a sequence of events. Right. Eventually, once we get through our trial, we'll have an outcome. And all of our outcomes, once we compile all those together, we'll be looking at a response variable. This slide is going to be repeated in the next few slides, so I'll let you just read this yourself. At this point, I'm going to ask you to pause the video, read this example problem. When you're ready, hit resume, and I'll summarize exactly what we're looking to do for this problem. So in this problem, we are going to be simulating the Baseball World Series. We want to see, is there an advantage between the home team and away teams? Start off by defining what each of these new vocabulary words are in the context of this problem. So the component is what we're simulating for this problem. Okay, so we're going to have a string of numbers, and each number is going to represent one World Series game. Okay, now it mentioned in the text of the problem that the home team has a 55% chance of winning each game, and the away team thus would have a 45% chance of winning. The trial, okay, is going to be the string of World Series games. Now we want to generate components until we have a winner of the World Series. Okay, we might have a winner after 4 games. It might take all 7 games. So we'll simulate as many World Series games as it takes until we have a team that won 4 games and thus has won the whole World Series. Okay, lastly, there's the outcome. Okay, and the outcome is which team won the World Series. Okay, did Team A win or did Team B win? Now let's go through those steps that were listed on the previous slide. Step 1, define the component, which we just mentioned was a single World Series game. Step 2, let's model or explain how we model the outcome. So it mentioned that the home team has a 55% chance of winning. Okay, because of that, let's use 2-digit numbers, and we're going to randomly generate a 2-digit number. If that number is between 0 and 54, okay, so there's 55 numbers between 0 and 54, that'll correspond to the home team winning. Okay, between 55 and 99, right, there's 45 numbers in this span. That will correspond to the away team winning. Right, so again, there's 55 numbers in this span. All right, that's the home team wins. There's 45 in this span. That's the away team, corresponding to their two percentages, 55%, 45%. Step 3, explain how you will simulate the trial. Now, before we do that, let's go ahead and generate some random numbers. Okay, now ignore this, that's incorrect. Right, on the TI-84, you're going to go into the catalog, so hit second and then 0. Hit the R button, which is above multiplication. Go down to rand int. Okay, stop there. On the 89, hit catalog, second 0. I think you have to hit F3 on the 89, and then look for rand int. Okay, once you have that, hit 0, hit the comma button. All right, type in 100, you close parenthesis, hit enter. It'll give you a random number between 0 and 100. Now, actually, that's not correct. We don't want it to be between 0 and 100. We want it to be between 0 and 99. Okay, because we don't want to include 100. All right, so that gives us a random number between 0 and 99. If we have a number between 0 and 54, that corresponds to the home team winning. All right, if it's between 55 and 99, that corresponds to the away team winning that game. All right, so let's head back up to, actually, before we head back up to step 3, all right, let's talk about the trial again. Now, the trial is the full World Series. Okay, so let's say we did that 7 times to get 7 games. Now, if you just hit enter again 7 times, you'll see that generates random numbers again and again. Okay, and we have probabilities for winning each game. All right, so step 3, okay, we're going to record wins for teams A and B. A is the home team, or team A, I should say, starts at home. Team B starts away. Remember to swap chances of winning after the first 2 games and again after the next 3 games. Okay, so for our first number, mine was 44. Okay, Team A would win. All right, my second number was 97. Team B would win. Okay, now after two games, they flip. Okay, now Team A is away. Okay, my third number is 22. B is home at this point, so Team B wins, etc. Before going on to 4 and 5, let me clarify a bit as to what I've done. So I wrote all of my components for my first trial in this box here. Now for the first 2 games, A is at home. The next 3, Team B is at home. And the last 2, A is at home again. Okay, now game 1, okay, our randomly generated number is 44. That will correspond to the home team winning. That's Team A. Okay, our next number is 97. Okay, that was in our 55 to 99 range. That's the away team winning. That would be Team B. Okay, this next batch, the middle 3 games, Team B is at home. Okay, 22, that's in the 0 to 44 range. That's the home team winning. Team B is at home for these middle ones. Okay, this is away, that's A. This is Team B. Okay, and then the last, okay, Team A is at home for these last ones. Okay, this is in that first one, this is Team A. Okay, and this is Team A again. Okay, the one that gets to 4 games first, whoops, I don't want to do that, but we can see A gets to 4 games first, so Team A is our outcome. You get it. Okay, so number 4. Okay, state clearly what the response variable is. We want to know which team wins 4 games and thus the World Series. Okay, the outcome, the response variable, is the winner of the series. Okay, we want to run several trials. Okay, in our table here we have 5 trials. Okay, we would run that 5 times. Each trial we would generate 7 new numbers. We might not need all 7 to get a winner, right? But it's easier just to do 7 and only use what we need. Step 6, analyze the response variable. Okay, now we've done this across a number of trials at this point. I don't remember if yours just had 5 or 10 in your notes, right? But once all the trials are completed, we want to look at those outcomes across all the trials. All right, so let's say there were 10 trials. We want to say what's the actual percentage of World Series where Team A won versus Team B won. Okay, is there an advantage to Team A starting at home versus Team B starting away? Okay, are they winning the World Series at equal rates, or is Team A winning more often starting at home? Okay, is Team B winning more often starting away? Okay, when we state our conclusion, we always want to say something like the simulation suggests, right? For example, the simulation suggests that Team A has an advantage starting the series at home. They win the World Series 60% of the time. Okay, it's important to say something like this because this is just a simulation. Reality may differ from our simulation. Some common mistakes I see with these. Most common is that you forget to write the simulation suggests at the start of your answer. Okay, another one is modeling your outcome chances incorrectly, most notably not using two-digit numbers when they're appropriate. We'll talk about more about those as we go through this chapter. And lastly, we always want to run as many trials as we can.